Hello, Jim. Morning, good afternoon, good evening, good night. Welcome everyone for lesson 15. Today we're going to start working with the backend integrations. Actually, we're going to build more on the API front because like the backend per se, we would have done in the past lessons. Like in the last weekend project, we did those scripts for the tokenized ballot. Before we did the scripts for the hello world, right? So those scripts, they were written in TypeScript interacting with the blockchain. So, but they were already functioning. It would be your backend in this case. If we use like the blockchain as a database, you see that would be your in fact backend. And then in the past two lessons, we built a UI, a user interface. Today, we're going to build an API, an application programming interface, so that machines, bots, servers, they can communicate through our app. They can interact with our systems, okay? You're not going to expect a machine to go clicking on buttons, filling forms for doing actions, right? I'm not speaking about AI robots or things like this. I'm speaking about computer integrations, like a bank integration or exchange integration or mail integration. There are a lot of automations like this that we communicate through APIs. Okay, so we can't use UIs for serving connection to machines. They are not going to comply. Maybe now with computer use AIs they can, but usually we have much more efficiency when doing APIs, okay? Um, Layla, is that correctly?
Yes,
Good.
Leila, yes. Sorry, this is not relevant to what you were just saying right now. It's just that I missed yesterday's class because I was a bit sick. Um, and I just wanted to ask, when I was doing Mondays, I haven't gotten a chance to go through yesterday's class, but when I was going through Mondays, I was not able to run it on my VS Code. I was able to run it as an administrator on command prompt, but no matter how hard I tried on Git Bash or on VS Code, it wasn't working. Is that a problem or is it absolutely fine? It doesn't matter which terminal.
Yeah, so I could provide support to get it working on your terminals. If you share with me those problems in a GitHub issue, for example, then I can get it working on any terminal. Maybe it's an old version, how installed Node or something like that. But so long you have it working in one place, it's good. You can keep for today's and tomorrow's lesson. But if you have the time, open some GitHub issues, share with me those errors, and then I can help you to troubleshoot,
Okay.
okay?
Okay, thank you so much. Thank you.
Thank you. Okay, let me start with a more high-level conceptualization here because there is a lot of like critique on using backends. Why should we use backend in a Web3 application now? There's a lot of questions like this. And people, of course, we are not going to handle the balances of the users in a database because then we are a centralized party, okay, like a centralized exchange, and we know what can go wrong if we do like that, like FTX can happen and this kind of stuff. We are not going to handle the ownership of assets in a database, in a backend that we control, of course. We are going to use those APIs for doing programmatic access for things that are not critical, that people wouldn't trust us. The balance of the tokens, the voting rights, whatever, are still going to be stored in the blockchain. What I'm saying is to use things like this. Let me open a website. For example, OpenSea. Have you ever used this for NFT marketplaces and all? Buying, selling NFTs, browsing NFTs. So this is a website that is going to show NFTs on the blockchain, like a block explorer or something like that for NFTs. Yes. But the information is not going to come directly from the blockchain. It's not going to fetch from the front end to the blockchain. It could, but it would take too long. So if you open the network tab here, you're going to see that OpenSea, let me refresh the page. OpenSea is going to bring all of these information of prices, of NFT names, the images and all from a backend. There is a call here to a backend in OpenSea. Here, we have an open mic. Sort that out. We have a backend here from OpenSea, hosted by them, where they're going to bring all of this information. Okay, here we have preview, wallet, React, whatever. I saw that. Stop scrolling here. So these calls that we are doing, maybe it's too small for you to see, but you can open this network tab on your side too, on your side. You're going to see that there is a lot of calls for OpenSea like this. A GraphQL call gets information from a database, from a centralized database, with all of this information. Of course, they can lie. They can. But if they lie, it's very easy to detect there in the blockchain, and then they run their reputations. Whenever you do that transaction on-chain, you are protected from this kind of middle man-in-the-middle attack, spoofing attack, or something like that. Okay. So it is possible to use backends for Web3 applications. Whenever you want to automate a task, like doing airdrops, whenever you want to get speed in fetch information from the blockchain that might take a while. Someone asked about subgraphs and all that. This kind of backends and data aggregation tools, they are very useful. Okay, so yes, there is place for backends, for APIs and all in Web3 projects. In fact, in many places they are even missed. When you don't have that, you wait a lot for the front end to load, and now you're losing users. You are bouncing users. Okay, so you're going to learn how to do that. A very simple implementation would be doing a script like this using Node, that you, instead of answering from the console, like we did in the lesson 8 and in the previous lessons, you could answer from internet port in your computer. So instead of sending comments from the console line when running those scripts, you could make this process, this function attached to a port in your computer, your internet adapter. Okay? This is basically the only change. But then there are so many things to take care of here, of routing, of attack protection, authentication, passing the request and all, that it would take a long time for us to code all of that by ourselves. So we're going to use a framework, just like we did on the Next.js for coding the front end. We did not code HTML. We coded TSX that would be translated to HTML later. So here the same thing. We are not going to code the server. We are going to code for a framework called Nest.js, Nest with an S. That is going to code the web server for us. And we're going to see how that simple it is. Okay. We're going to go over these first steps again as a review. I asked you at the end of last lesson to install this CLI globally. So I have here a folder where I have created this project in the last lesson. Okay, with this project name. Let me delete that so I can do that again. RF, project name. Delete that and let me start again. I do have the CLI installed already. If you don't have, you can install it like this. If you don't want to use Nest after, you can just uninstall the CLI later. Okay, and here I'm going to use Nest to create that backend. The same thing that I was explaining about front-end frameworks would apply here. There are many different competitors. You can build the backends with Python, with Go, with Rust, with C, with Java, whatever. Using JavaScript is becoming like the lingua franca of the internet, of anything that we need to do is using JavaScript and TypeScript. It's becoming like the lingua franca of the web. both for front and for back-end applications, so that everything that we used in the past lessons, we can port here directly, okay? If you build a backend with C, you're going to have more performance. With Rust, we're going to get more performance. People say that. Yes, but sometimes no. When you are running these code like this server with good environments, with good configuration with Node or with Bun or something like that, you can get as many requests per second as you would get in a Python or a C server. Actually, Node, when you are using Node.js, we're interfacing with C under the hood, so there's no much of a performance loss of doing that as it was like 10 years ago. 10 years ago, this would be a crime. Do not build your backend with front-end code, of course. But nowadays, the industry is modern enough that you can build normally your front end, your back end, and now with the JavaScript, TypeScript is going to work like a charm. I'm going to prove that for you today. So we're going to install this tool, the CLI, and we're going to use it for creating a new project, mass new project name, mass new, and I'm going to give a name for this project, like token API. So this is going to be the name of my project. I'm going to use npm. I wish they had Bun as an option here, would be nice. But then we can install with npm and run with Bun. This would create a project for us with all of the necessary files for us to build this backend, for us to use this backend. Okay. So we are not going to have buttons for us to click. Things are going to be consumed programmatically. In fact, I'm going to show a way for us to click on buttons using this open API, using Swagger here. So it's going to be more visual for us. But first, we're going to start with just the normal API, okay? Actually, let me open this link here. We're going to need that in a while. So we are not going to use Node.js directly. We're going to use a framework that uses Node.js under the hood, okay? Then we're going to install and create a new project like that. Any questions at this point? You're following? It's working on a machine. That's a very important question, right? I have most of you with cameras turned off, so I don't know if you're nodding or if you're approving thumbs up, but okay, let me follow. So I'm going to enter this token API. Token API. Good, Nathan. Thanks for the confirmation.
Hold up for a second. I'm just double checking that I put down the correct things into my system.
Yes, Lena. Just for review on the organization here, I'm in the 2025 Q1 folder that we have been using for past lessons. I created a folder, the app, and inside this folder, I have the front end here. So I have the front end with the scaffolding, with hard hat there too. And now I'm creating this token API as my backend, okay? Keep some organization like this would be good. It's not necessary to be like this. It's just that it's going to help us tomorrow when we are integrating those. And I'm going to do this next step now. I'm going to run this where I had it somewhere. Let me see. It's in my terminal here. I'm going to run these commands, enter the token API, and then I'm going to do the npm run start. npm run start. This is going to start the API, start the server. Nest.js is going to host this application online on my machine now. And then I'm going to be able to consume it from the port at 3000, just like we did in the past lessons. If I go for localhost 3000, I'm going to have this answer, hello world. It's different from the web page that we had. Here we are just having a string, could be a JSON object, something like that. Okay, we're not going to spit out HTML here for the browser. This is meant for being consumed from machines. Let me open another tab here, and I'm going to do that on the command line. For http dot slash slash 127.0.0.1 at the port 3000. We have this answer of hello world. Okay, no HTML, nothing like that, okay? Just a string, just text here. Your API is running. You have a API running on your computer. If I stop this here, nothing is going to come from this port anymore. Can't connect to the server, okay? So the framework makes it that simple for us to get started. Lauren, do you have a question here?
Yes, can you get back to the other command line window, please?
This one?
No, the other one. Yeah, token API, is it a folder or?
Yeah, I created the project with this name, Token API. So
It's not project.
the
It's not project name. You renamed it.
as Token API, yes.
Okay, and then you
It's
go
not,
into this folder. So project name being renamed Token API.
yeah, like this.
Okay.
And then you do run start.
Okay, thanks. I missed this part.
So when we do that, the API is already working. So I abstracted hours of development for you, and now we can just you see if it will start. Okay, started. Now we can just ping that port and it's going to answer this hello world. Okay. How is that possible? Nest framework is creating all of these routers and resolvers for us. As soon as we run this command, if we do the production, is going to be a big JavaScript file that would handle this simple script called main.ts. Okay, with React, it's very difficult to understand this flow and all the structure. Here it's going to be very simple. It's going to call this simple script called main.ts that is going to create one application based on a model that we are going to configure. Let me show that for you in Cursor. Okay. Open that folder in VS Code, open that folder in Cursor, open that folder in whatever IDE you would prefer. And let's understand this modular approach, this modular architecture that's is so powerful. A lot of people are afraid because they think that is complex. I need to create models for the things that I want to use and all. Let's demystify that. Okay, let's open this main.ts script here. So it is a simple function definition and function calling. How many times we did that in this bootcamp? I could call this function main like this or whatever and call this function. And if I do something else inside this function, like console log, I am just running script. I've replaced my main.ts with this. Now I'm going to run this server. Stop here. Let me run this server. This is just going to execute that TypeScript. It's going to console log something. It's going to say this is just running a script. I'm just running a script, and that's it. See? So there is no component lifecycle, blah, 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 that we need to use hooks and this is going to be bundling an application that is going to be passed for the browser to create the HTML, blah, blah, blah. Forget all of that. For the backend, it's completely straightforward. We have a script that whatever we execute here, it's going to be done. It's going to be hosted there in the server. This script is built with two components, two lines of code here. One is the so-called nest factor that we can totally abstract away. It is a factor, it's a DVD player. It is a PlayStation that you put the game there and it plays. I'm getting old, I guess. The modern generations, they don't know what's that. They just know Netflix and all. But this is a player. This is an executor. You put some media on it, it's going to play. Okay, this is the next factor. We don't need to understand it in itself. What we need to understand is that we are passing a music for it to play, a video for it to play, and it is playing. Okay. And then we are asking it to listen in that port. If we want to change that port, we can put another port here. And this is the main script. This is what Nest.js is doing when we run that script. Okay. What do we have in that model? Let's go for this app model. We have defined two elements that are not elements scoped out by Nest.js, are elements that are part of the backend architecture. All the backends, they have these elements of controllers and services. Okay, we are going to understand that. We have the documentation. And this model is empty. Look at the class at the line 10. It's empty. I don't have anything there. What is happening? We are using those decorators to create those classes for us. So I don't need to code the class myself that the app model has this and this and that. No, I just give some decorators and the framework is going to code that for me. So I decorated this as a model that is going to have one controller with this method called getHelloWorld, decorated as a get. The class is decorated as a controller, and is going to be using one service decorated as an injectable service to handle this call. So here, it is almost like using Lego blocks and pieces. The modularity here is beautiful because of that. I don't need to worry with how to create a controller. I don't need to worry with how to create a get method. I don't need to worry on how to create an injectable service. I just need to worry on building what I want to build, on doing the return function, on doing the minting of the tokens, whatever I want to do. And the framework is going to handle everything else. And I find that beautiful. It is almost as a no code. You're seeing this framework for the first day, might be a little complex. Maybe you don't know those backend terms of controllers and all. It might sound complex, but the execution here, trust me, it is marvelous. I don't need to write a single line of code to specify how to make this controller. I just need to put the correct decorators, and the framework is going to code all of that for me. Almost like AI before AI. Okay. So let me show you what is happening. Okay. If you already know all of these things, what is a controller, what is a service, and all, maybe this lesson might be a little boring, how to handle those requests. Now, if you know all of this, I'm going to explain that in very simple terms for newcomers. Okay, so have some patience. Bear in mind that I'm going to drop some of these explanations here. Okay, so in this architecture called REST, RESTful architecture, you have the figure of controllers and services, either in Node, in Java, whatever language that you are implementing, where the controller is going to handle, manage workloads, things to be done, and the service is going to work on those jobs to be done. Okay, so that is an analogy here on a stereotype. Okay, a manager would not do the work by himself or herself. A manager would only manage the incoming work request, decide which worker would do the work, would split the work in sizable units, would pass the work off, If the work would require multiple people working on those things, it would orchestrate those people who receives what, who goes first, who goes last, and the worker, the service, in this case, the worker, would receive the request for the manager. It wouldn't have the big picture. It wouldn't know, like, I'm tightening this bolt. Why? I don't know. I might be building a tank. I might be building a robot, an airplane, a boat. I don't know. I'm just tightening this bolt, okay? So it is only concerned with that task, not responsible for the big picture, and it's going to handle the work and it's going to complete the work for the manager, okay? So this is why the controller usually is managing the incoming HTTP request, deciding who is going to do the work and all, and the service is going to do the work itself. Here we have a very simple implementation. The controller is asking the service for getting hello, and this service is returning hello world. I could just copy this and paste there. Yes, I could. The whole thing would be much more simple if I did that. But it would be architecturally wrong. What does it mean to be architecturally correct now? We are speaking, people, about maintainability. Okay, if someone else is going to append this code or give maintenance of this code and all, they would expect the architecture to be compliant. Okay, this is a very big problem in backends. Learn how to code a backend is very easy. Learn how to code a proper backend with good architecture and security now is very difficult. Okay, and people are vibe coding things out there, vibe coding apps, and now the front end part is looking beautiful, yes, but the backend part, authentication, security, it's totally messy because this is an architectural problem. Okay, imagine living in a house that is very beautiful, but you don't have plumbing, you don't have electricity, you don't have internet, you don't have air conditioning, you don't have illumination, you don't have air circulation because the architecture is incorrect. Okay, so this is one of the things that NestJS would solve very well, and all the frameworks would solve very well too. That would be creating a good architecture, okay, an out-of-the-box application architecture, which would guide us to build highly testable, scalable, loose coupled backend as well as possible, even being a newcomer. Okay. Yes, Arthur? It seems that your microphone is not picking your audio very well.
Can you hear me now?
Okay, much better.
Sorry. There's the in app services, there is the keyword injectable. Would you care to spend a few words on what that means?
Yeah, yes, I can demonstrate that very quickly. In the app model, we are injecting this provider for everyone inside this model to consume. If I remove this provider from here, when the app controller try to use this app service, it's not going to be there. Okay, I can try and run that start command again, and it's going to say I couldn't find this service. This is one of the modularity parts that allows you to swap things out. Okay, we are not going to use this feature in this bootcamp, but it's possible that you inject all the things. So we have now this problem. The app service that needs to be injected, it's not being injected here. And those dependency injections are interesting because they can swap it. It can be swapped out. You can change a model for another model without changing too much things. You just have them to work in the interface level. Okay, if you apply solid philosophy, you can swap them out and inject something else, and you can even inject this without loading the application. It's crazy the things that you can do. You can inject a mock when doing the tests. Okay, when you want to do that with all the frameworks, you need to write a lot of code for handling this. NestJS give all of that out of the box for you. Okay. This is what it means to be injectable. And you can read all of the documentation here. So this is the introduction. You have a full path ahead if you want to master this, just the same things we saw on the front-end development. Okay. Enough of introduction, half an hour on this already. We are going to code some things here. So for example, where is my other reading? For example, I want to get information from token contract address, token name, total supply, balance of a given address, and all. Okay, let's say I want to have those functionalities in my API. So I'm going to create another get method called contract address. Is going to be on this path of contract address. And I'm going to ask it to return this function from the service. Okay. Let me implement this real quick here. So I'm going to get another get method, get contract address. The function name is not that important. The important part is the path. It needs to be lowercase. It needs to be camel case, and now we cannot. Here we would work if you use uppercase, but this is going to be a URL. It's going to be a path, and so some integrations might break if you have like uppercase and symbols and things like that. And then I'm going to implement this get contract address there in the service. Get contract address there in the service. Okay. This now provides the ability, the feature, the functionality of calling this endpoint, and is going to return this other hard-coded string. Okay. These function line 5 and line 9, they are very similar. I'm just changing the function name, right? And here, instead of returning this string directly, I'm going to return an object. Created the object in the fly. This is not very good. It's a little smelly code. But for the sake of time here, we're going to go like that. So if I start my API again, we start my API. And if I call this method now, token address, actually no, contract address, not token address, contract address, it is going to give me this answer. If I call the normal root path, I'm going to have that. But if I call this path, I'm going to have that result. See? The framework already implemented the code to route correctly the calls based on the URL and to trigger the correct execution. So this is going to pick that address, store in the server, and is going to do the correct computation using that. So it's different from the user interface that we had in the front end, where the user could change the code, could have access to the code there in the front end. Here we are only interfacing through calls. So if I have a mint function here, the user would only interface with the internet port. Yesterday, if we applied a mint function, the end user would have the private key of the mint there, everything there, okay? So whenever you implement things on the front end, it's going to leak for the end user. If you want to do something with your private key, with your server key, with your signature key, you need to do that in a backend, okay? So your keys are safe. You see here how I cannot like change the color of the background like I did. This is just giving me a strict object as a return. I don't have even access to the code running that, okay? I'm not going to run the server on my computer when I do the request. It's completely decoupled, okay? So let's do this second example. Let's get a token name. How to get a token name from an address? Do you know any TypeScript library that can do that for us? any library that would receive a string and some configurations, and it could return this information from chain, we can use VM. Yes, that's correct. So let me install VM. I'm going to stop the server again. Stop the server. Like this. I'm going to install VM inside that token API. Why not? We have been using VM on the front end, on the scripts, and now we did that with Hot Hat in the past. I could install Hot Hat here, but it would make the server a little more heavy. Okay, if I want to do microservices, run that in a Lambda function, something like that, I would keep it as small as possible. So I'm going to add VM only to keep it simple. And I'm going to do the calls using VM. Okay. If you want to keep your server updated with all of the changes that you do, you can run this command here, npm run start dev to .dev. Okay. This command is there on the package.json. Start to .dev is going to start Nest server in the watch mode. So everything that you run, everything that you change actually in the scripts, in the files inside Nest, is going to rerun the server. Okay, and it's going to update. It's very useful. I'm going to run it with that. We will run start dev. And now we're going to use VM to do things in our API, just like we did in our scripts. We do have scripts from lesson 8 and the previous lessons where we used VM for doing on-chain interactions, right? Let's use this again in the service here and consume these things in the controller. For example, how to implement a get method for the token name. In the controller, it's very simple. I'm going to get a token name that is going to come to this address and try to return the name, right? So I'm going to get the token name in the controller. That's the easy part. So just like contract address would return the address of the contract, get token name is going to return the app service token name. In this situation, I had the answer atomically answered for me because it was a string. In the get token name call, I need to do an asynchronous call. So this is why I'm marking this call as async, okay? Next.js knows how to handle that, how to do timeout, rate limits and all. So you just by marking it async and doing this await, it's going to handle things for us, okay? And I'm going to create that get token name with that same technique we did yesterday, control dot, command dot. I can ask the app service to declare that function, get token name, and it's going to be here. It's going to automatically create that method for me. Not implemented, it is an error as intended. Okay, I want it to be like that for now. It's just to show that now if I test this, if I do this call in contract address, it's going to work, but if I call the token name, it's going to give me an error, internal server error. And I can see the error here, method not implemented, okay? So we did the controller only. If I'm going too fast, please let me know, okay? I can wait for you to type or make your notes. So we are at this step here, the controller get token name. For creating that method in the service, we will need to fetch the API because we're using VM and not using Hot Hat, we're not using Scaffold ETH. We're going to need to fetch the API for creating the contract with VM. We know that VM requests the API as a parameter here, right? We saw that in the past. So let's solve this first. I'm going to pick any myToken.json from any ERC20 that you compiled before. Pay attention. In which lessons did we use tokens in the past? Do you remember? Nope. Token sale, tokenized ballot, right? 12, 13. So you can go there for any of those lessons. For example, token sale. It can go for the artifacts. You can pick inside your contracts any myToken.sol that you have and copy this myToken.json. You should have it there from previous lessons. Okay. So pick any myToken.json that you have from any ERC20 that you have compiled before. Any is going to work here. Okay. So I'm going to pick this myToken.json and I'm going to bring it there for my backend token API inside a folder inside source where I have this explanation inside source in the folder called assets. Okay, I could name it differently. Assets seems like a good one because it's going to be static. It's going to be served in a static way. So I'm going to create a new folder called assets and I'm going to paste this file there. Okay, I can see it there. I can see this folder assets. I can see this myToken.json, and I should have an API member there. I should have a bytecode member there. Okay, this is the myToken.json that we use in the token sale contract. You can use your tokenized vaults to any ERC20 compatible one. Okay. And then you can import this token JSON from myToken.json. We did that in the past, but I mentioned that this is a little wrong with a lot of quotes here, kind of a Jerry job. So, because JSONs are not objects. JSONs are like text file, more close to a CSV file than it is of an object. We would need to serialize it or some way for using that as an object. Okay. There is a flag that you can apply on your TypeScript configurations to tell TypeScript to chill out. Okay. You give it a bribe and then it stop complaining, something like that. So we are going to go there for the tsconfig.json, and we are going to add this option, resolve JSON model, and we're going to mark it as true. So we're going to go for the compiler options, and we're going to add this resolve JSON model as true. Exactly this instruction that I have put here. Open your tsconfig.json, search for compiler options there, and then add the resolve JSON model as true. Okay. So the line 8 allows syntax default imports, which is there already, and line 20 together, they would allow you to import this JSON. Now this error goes away. Now we can commit this little crime without any punishment. Okay. We did all of that just so that we have the API now to use inside this call, inside this get token name call here. I did something wrong, it seems. It seems like, okay, good. Now we can program this get token name. I'm going to create a public client using VM. We did that in the past, lesson 8, right? So how to do that? I just import public client from VM. I import Sepolia from chains. Let's see if I remember that. I guess I've noted this. No, I haven't. So I can import Sepolia from VM chains. Thanks AI for helping me. Let me add that. Send to the chat. You're going to import create public client from VM. This the IntelliSense can help you. You can import Sepolia from VM chains. Okay. You can import HTTP from VM. We need to put RPC endpoint URL here. We solved that in the past, remember? How we use it is transport HTTP. We use it in Fura, Alchemy, whatever. So for example, here we can use like quick node. And we need your provider key. Yes, you can copy that from any past exercise that you have. I'm going to show that just in a while. Address here is complaining because a string is not assignable to the type of 0x string. Do you remember what is the correct type to use here that you can import from VM? Let's see if you paid attention to that.
As address.
As address. So I'm going to force this string. I could use 0x string, it would fix, okay? But I like this approach because it's clean. I don't need to import anything else, but it's not that readable. So some people prefer to do like this, address. And I don't disagree. Importing address from theme can improve readability. So I import address from Vim, and then it solves this problem here. Okay. Then it would return name. It's complaining that unknown is not assignable to type string. So I'm going to make it as string. Let me see if that works. Yes. Just the type checks. Type checks are being very strict here. So the address needs to be as an address, and the name needs to be as a string. Okay. When we compile and run the things, is going to go well. It's just TypeScript being strict on those checks here. Okay. So how to solve this transport part? How we did that in the past lessons? We would have environment variable, a .env, like we did in past lessons. For example, if we pick our .env from project 5, I'm going to copy those two. And I'm going to put them here inside our DApp, inside our token API. I'm going to put the .env here. Okay. This .env is something like that. I have my private key and whatever API key. Okay, let me just remember what I'm using. Alchemy, okay, using Alchemy. So I have my private key and whatever API key here in data.env, right? If I try to use this here, if I try to use this transport here directly, picking my environment variables, this is not going to work straight like this. Okay. For example, let's see how we use it. Let's see how we use it that in our project 5. What was the one that we did that script? No, project 4. Scripts. Deploy with VM. Okay, this one. So how we did here? We had that transport like this. You should have that on your side too somewhere. So we did transport like this, right? And we had these provider API key, deploy API key like that, right? This is not going to work straight out of the box. Let me show you. Let me do a console log provider API key. Let me do something like this. Console log provide API key, and like that. When I start my server, my provider API key is empty. I don't have anything there. Okay. What's the problem? I don't have .env. Okay. So let me do like this. Slice from 0 to 5. So my provider API key, it's nothing, it's empty. Okay. How to solve that? How to actually make an SJS to see my API keys? We can import .env, just like that. Okay, let me stop my server. I'm going to import .env. There is a model. Let's see if I have this explanation. There is a whole model that we can use, the configuration model, that is going to make this a little more organized. Okay, so instead of getting the string from .env, we could use this config model. Okay, but it's going to do the same thing. I put here just as an introduction to the models. I'm not going to do this path. I'm just going to go with the .env as we did in the last lessons. Okay, so I'm going to install this .env package. And I'm going to configure this .env at the main.ts. Okay, I'm going to add this configuration at the main.ts to import .env.config at the beginning of my bootstrap function. Okay. I'm going to pick the main.ts and I'm going to import .env config before my bootstrap function. Just by doing that, I don't need to configure anything else. I don't need to use anything else. These environment keys are going to work. If your environment is looking like that, private key, URL, token address, something like this, it might work. Okay. Token address, I didn't even use, but I could swap like the address that I had coded to this token address here in the README. Okay. Just by doing that, when I start my server, when I restart my server, npm run start dev, I'm going to have a .env installed and my API keys are going to be loaded. So waiting. Let's pay attention to this console log. Wait, what happened? Did I do it correctly? Let me see. App service, provider API key, Alchemy API key. So I 0 to 5, my Alchemy API key. It should be there. I guess I'm missing the .env .env.config. What's the correct way again? Import everything from .env. I did that a few times. Yes, this is the correct way. I'm sorry. export everything as .m from .m. I guess this is the correct one. I still not provide API key is not coming. What? Yeah, I did something wrong here. Yes, Lauren, you have a question in the meantime?
Yes, sorry, I can't compile the code because there's still an issue with the assets my token JSON, and I have updated the TS config file as requested, but it doesn't work. Can you show back the TS config file?
Yes. This is the TS config file. You should add the resolve JSON model to true at the end of the compiler options, and then make sure that you saved it.
Yes, so this is what I did. But still, when I go to the app.service, the asset my token import is still in red.
Are you sure that you have put the mytoken.json there in assets?
Assets. Where is asset? Sorry, in source.
If you, yes, in source asset mytoken.json.
No, I don't have the file. Sorry. Where is the file?
Okay. You probably have missed this step here.
Aha. Okay. Okay.
Okay, this is step. So you're going to pick one of your mytoken.json files that you have from previous projects, and you put that inside the source assets folder. Okay.
Sorry, I missed this part. Okay.
No worries.
It's a lot of instruction today.
Yeah. Trying to go slowly here. Let me restart myself. Maybe this is the problem. Let me see. I have my hopes high here. Provide API key. It's not giving me anything. What is happening? I swear I had this working.
Could it be about where the .env file is?
It is in the source, right? How can be API key? Am I doing that correctly? Yeah, it should be correct. Wait a minute. I'm doing something wrong here. Let me do this token address. Let me add the token address to my .env. Just test this, and I need to isolate. If everything fails, we are going to use the model, because the model is more certain to work. Maybe we're going to consume more time of today's lesson on that. Let me do this. Let me go for my environment, and I'm going to add this token address 0x something. Okay. I'm going to pause the share. I'm going to go for my environment, and I'm going to add the token address as we have in the service. Okay, let me do that on my side. Okay, now let me resume share. What I did is to populate a token address in my .env with something like this. Okay, I imported .env there in the main.ts. This should work for everything. Now in the app service, let me remove this and let me return token address. Let me just do one thing first. I want this there. Okay. And instead of returning the code address hard-coded, I'm going to return the process env token address. Let me see if this one works. Done. As a string. Okay. TypeScript is being too strict here. Maybe they updated the version from when I did this exercise back there and what we have now. So let me test this Let me test the contract address to see if it works. Contract address, and it is working. Okay, so maybe it was just a misconfiguration on my side. If I try to get the token name, it should work too. Test that. Token name. Yes. Okay, so it's working. It seemed that it was just where I was doing the console log. If I do the console log here, I should have paid attention to that. I beg pardon for all of you. If I do the console log before the injectable, I'm not going to use the main.ts. I'm actually going to use only the standalone service. When it is injected, when this class is injected, then it is inside the model, and then I'm going to use this configuration, okay? So it was my bad. I was putting the console log in the wrong place. And when using inside those methods, it should work. Okay, so following the documentation as I have put it there in the README, it should work for you. If you want to test that, yes.
Could you go through all of it a little once again, please? Because there was
Yes.
a lot of screen changing and whatnot.
So let's start from using environment variables again. So you probably have installed .env, right? I'm going to put this on the main.ts again, because I'm quite confident that this is the correct way to do this import. Okay. Then you're going to configure your env example with something like that. With the token address, your API key, or if you don't want to put just the API key, you can configure with the whole endpoint URL here, straight out. You put the whole URL there on your .env, you put your private key there where you're a meter of this token. And then you modify the get token name service, get token name service, and the get contract address service functions in the service actually. You modify those two. They get token name and they get a contract address with this. Okay. And you're going to need to fix these type checks. The line 22 address, you need to put as address and import that from VM. And the line 26 name, and you should force it to be as a string. Okay. Lauren, do you have a question?
Yeah, on the main function, do you still have your .config command instruction?
I've put exactly like that. Let me test this again. Contract address, yes, it's working.
So you remove the .config, right?
Yes, I kept exactly as we have in the README. If you follow the README, it should be working. I should have followed the README with more attention.
Yeah, you should.
You see, it's very common. Okay, questions here up to this point? Need an extra minute? Let me know.
Mateus, can you show again the curl function, please?
This function?
No, the curl code in the
Here. Like this. And I'm going to replace the curl for Open API for Swagger right now. Okay, so doing those calls is a little tricky. I would introduce the config model, okay, for showing how those models would work with Nest.js, because this model now you can plug in any model like database collection, Swagger, configuration, testing models, whatever. You can just plug them very quickly. But I'm going to skip that because of the time that we spent on this bug, my fault. And I'm going to show this other model, the Swagger model. Okay. So we're going to jump for this step here because we have like 20 minutes or so for concluding this lesson. Arda?
Could you share in chat the token address that you're using?
It's the same one as we have here. Somewhere here. The same one. And here you can use your token address from your previous deployments on this bootcamp. It can be your tokenized ballot token, for example. Okay. Any other questions before we do this Swagger model? Okay, we're going to install this model with this command. Let me show what we're going to install first, right? This Swagger model is a model that is going to automatically create a documentation for our API. It's not using AI, okay? It is using an algorithm to read what decorators you put, what controllers you have and all. And this is going to create a developer docs on the fly, interactable developer docs following the open API specifications using a model called Swagger here, similar to Postman and others that you might have used it in the past. So I'm going to stop my server. I'm going to install this Swagger model. I'm going to configure this model, and then I'm going to restart the server. Or I can restart the server in watch mode and then configure the model. It would do the same. The configuration is very simple. I just need to add it to my main.ts. This document builder function that I import from Nest.js is going to automatically read my app and create a documentation for it based on the configurations that I pass for it, and is going to set up this documentation in a route like API, docs, or whatever route that you want to put here in this string. Okay, so then when you start your app, it's going to have this route with this documentation appended to this app. Okay, I have these instructions here in the README too. Okay, so we're going to configure our main.ts like this. I'm going to open my main.ts. I'm going to paste everything. I need this .m.config. Should have put it there. For some reason I didn't. So I need to keep that .m.config. Okay. So pay attention when pasting the main.ts, you should keep this line of the .env.config. Okay. Paste it for here in the chat. So I'm going to import the Swagger model and the document builder from Swagger. And this is going to create this automated documentation for us in this route API. I could put anything like my docs or whatever. Any route that I put here, when I save this and when I start the server, now I can navigate to that folder, to that path actually, in my local host. Look here, I'm going to do an exercise in the browser first. Localhost 3000. Let's wait for the server to go. Wait. So localhost 3000 is like that. If I do localhost at the path token name, is going to answer like this: an object, result, cheesy pizza token, whatever, with a pretty print extension that I'm doing here. But if I go for the docs that I have just created in the route of API, now I'm going to have a user interface again. Okay. What is this user interface? The programs are going to use this user interface for interacting with my API. No, it's just for humans, for docs, for devs. So, for example, if I'm speaking with this API and I want to know how to get the token name, here I have the specification, no parameters. These are the responses. I can try it out, execute. This is going to do this call of the curl for us under the hood, and it's going to get the result and it's going to print out for me with all of the necessary headers and all as printed. Okay. So it's not a component for your API. It is more like a tooling, a dev tooling for us to interact with it more easily. And it's going to make our lives easier for passing parameters for it, for inspecting the return values and all. Okay. So this is the Swagger model. Configure it in the main.ts, install it on your NestJS project. It's going to be one of the many models that we can attach here. Okay. Now it's easier to inspect things. You can inspect the contract address, try it out, and let's execute. Let's inspect the token name, and we can do that very quickly and easily now, just click on buttons instead of typing the comments in the CLI with the curl. Okay. So we completed the Swagger models. Any questions up to this model? Yes, Arda?
Sorry, it seems like I'm the only one with problems.
No.
So we installed this Swagger in the D app folder, right?
No, in the folder
Open
that you
API.
created your API.
Okay, so
So you should be inside this folder here. Okay, for the .env, for the Swagger.
yeah, so it's giving me an error resolved problems for some reason when I try to run it there.
If you run it inside the app, you have messed your project because your project is inside another project now. So you would need to remove the package.json, you would need to remove the package lock, everything you have on the app and put it there. Okay. Inside your D app folder, you should have only those two folders, nothing else. If you have a node models or package.json, you should remove it from there, okay?
Yep, there's
Laura, do you
nothing.
have
And then inside token API, I'm running the Swagger and it still says error resolved, big errors. I don't know what it is.
So when you are on token API, you are inside this folder, and then when you add this command, npm install nest.js Swagger, it's giving you problems with this.
Yes.
Could you add .env? It worked for you?
My .end is there.
No, the .env package, this package here.
Let's try that again. I did, but no, it's giving me saying 2 errors.
So it's probably like a configuration problem of your, it's back like 1 hour ago. In the probably it was a configuration error in this first step of getting started on installing the Next.js. Maybe you missed a folder or did in the wrong place, created inside another folder.
I mean, everything was sort of running until we started manipulating the token contracts.
So
And
this
then
worked, VM worked.
those worked, and the curl with the contract address was working.
So if this is not working, something is very wrong with the project. Like if npm install savedev.env is not working, then something is broken there.
Yeah, I'll probably restart the app.
And if you still have issues, you can open them on GitHub. I can go through your code slowly to see what might be the problem. Because here it seems that it's not a problem just about the Nest.js configure model. It's a problem of installing things like .env should be very straightforward for you to install there.
I mean, I already installed it. Now it's not linking something, I don't know. But whatever, we'll fix it later.
Yeah, you can try deleting your node models, delete your package lock.json, and then install again. So these kind of things can work more easily. And we had Laurent and someone else with the hand raised.
Yeah, in the Swagger, are we able to input stuff because I don't see the input, or it's because it's a get function only?
Yes, we're going to do that right now. By doing all the get methods where we have parameters and we have carries.
Okay, fine.
It is the next thing that we're going to do. Who had their hand raised? Was Ulas, me, or someone else? I wasn't checking. So let's go for these methods. We have about 10 minutes. Probably we are going to leave these post requests for tomorrow's lesson. Let's see how fast we can progress here. And we're going to do those other three routes. Get total supply, get token balance by passing one address as parameter, and get the transaction receipt by passing a hash as a carry parameter. Let me explain those three first. Actually, those later two of these, because the first one, it's the same thing as we did as the token name. I'm going to fetch this information from the blockchain to get the token name. Total supply is the same thing. I'm just going to go there, fetch this total supply, and answer back to the person asking. Nothing new here. So I'm going to declare the method get total supply. I'm going to declare the method get token balance. I'm going to declare the method get transaction receipt there in the app service. Okay, those are going to be like this, not implemented. Okay, just do a control dot or command dot, and you're going to get those automatically placed for you, just so that we get those errors out of the face. We have this error for importing parameter and for importing carry. We are going to solve that just by adding the import from Next.js common. Those are functionalities from Next.js for handling those requests, where I can decorate the request of being in this sort of a parameter or a query. Okay? I have this explanation. What did I open with Firefox? I have this explanation in the documentation too. So when we go for the controllers, when we go for those requests, request object, we're going to have a lot of different decorators that we can put, like body, like carry, like parameter, like headers. I can ask Nest.js to pick those pieces from the request and bind them to variables, so that when I'm using TypeScript here, this variable address is going to be bound to this parameter address here that's going to be automatically calculated. This hash is going to be bound to a parameter hash that's going to pass to the request and it's going to be automatically populated. Okay. You don't need to do that on your side. I'm just going to show this, like I'm going to do the same address that I'm passing here as a result, and I'm going to do the same hash as I'm passing here as a result. Okay, just for us to understand passing those parameters and carry parameters. Okay, then later we're going to undo this change. Let's go there for Swagger. Let me refresh. I don't have my server running. Yes, I don't have it. And I'm going to show what is going to happen when I pass this information, when I append the path with those special tokens. Okay? For parameter is going to be, the special token is going to be those two dots. I don't need to include the two dots. This is going to be omitted by the request processor. In the carry is going to be that interrogation mark. This is not about NestJS. This is about how those requests are handled. So if I pass something here, let me try out some address. And it's going to be ABC123. And if I execute that, I'm going to extract from this call ABC123 as this resource that is being translated to a string. So I could even validate if this is a string, a number, an address. I could say invalid address because it doesn't conform to this. I can automatically pass schemas for my objects and ask NestJS with the proper models to validate this schema for me. This is a big thing by itself. Validate if this user exists in the backend, validate if that smart contract exists in the blockchain or anything like that. If I want to pass more parameters, I could add more here, that, and that, but it can get tricky. A good way to pass a lot of things is by using carry parameters. Right? This is a query parameter. Look how it's going to be passed. Transaction received, question mark. The hash is equal to, this is a carry parameter. And if I had another thing, I would have an AND symbol, and it would append here. This is a carry parameter. I would have all the variables and all. I could pass a lot of different objects, even in different orders, and the request would be properly passed for the API. Okay. So you remember in the past lessons where we passed parameters to run the script. I'm going to cast vote for this proposal ID. That ID was a parameter I passed it for the script, Now I can do that with those API calls by using those requests like this. Okay. NestJS is helping us to handle this. So let's implement those. Get total supply first, then get token balance second, and then get transaction receipt and third. See what I have in the documentation. Let's do get the total supply first. Let's implement that. I'm going to copy get token name, and I'm going to paste here. Now you're going to tell me what changes I need to do for making that function to work properly. It should be async, right? But this is going to return the name. I want to return a total supply. What I need to do? Yes, we're going to change this function, get total supply. What lines should I change? Line 38. Okay, instead of name, it's going to be total supply. Good. Supply. Function return type, it's going to be a number, a big number, if we recall it correctly. So what is the function name here? Total supply. Total supply is going to be a big number, right? How to convert from big number to number?
You have to put the n on the end of the 0 n.
Yeah, but also I can use that function, format ether, that is going to pick a big number and is going to translate it to a string, format ether. This total supply big number is unknown, so I need to put this as big int, and then I'm going to return the total supply. I did that quite fast because we did that in the past exercises. Remember, I told you that doing those tests and scripts would pay off, like 2 for the price of 1. Now you can copy those operations that we did in the past, and you can reapply them here inside these applications. Doing those scripts was not a waste of time. You can just copy and paste. We can reapply what we have learned. So now when I ask the get total supply, let's see if this is going to work properly. Get total supply. So this was the result. We could even go more fancy. I could pick the symbol. The total supply is 100, and then I would display the symbol. Since I have the token name there, I can pick token symbol and display here. Okay, you see where I'm going, right? And here we don't need to worry with the whole life cycle of the component logic and all that we had with Next.js. It's straight out copying from our scripts and applying here inside this structure. I would suggest us to organize this a little better, because we are repeating this public client code again and again. So what I could do is to do a constructor where I define the public client, similar to what I would have in a smart contract. I can have a state variable, something like that, like this. I can define a public client variable of this class. Okay. We ended up not using the config service, so disregard this. I'm going to use the normal URL that we had here with the .env. So don't worry about the code that I just pasted. And we're going to do that in the constructor. Let me paste that for you in the chat. So for example, this is how I'm doing here on my side. And instead of repeating this public client creation all of the time again and again and again and again, I could use this public client. This is a functionality that we can do with TypeScript. What's happening here? I can do that with TypeScript. The classes can have these members that I can define in the constructor when the server starts. And then this object is going to be kept on memory. Every time I need to use that object again in future calls, I can just call it from here. Okay. How to get a token balance based on an address? We did that already. Compiler knows how to do that. It seems like it's correct. Yes. I'm using a cursor here, so it's suggest using Cloud 3.5, 3.7 to suggest those functions. So we did that in past lessons in this bootcamp. We don't need to spend more time on this. We know that this is how we get a balance of an account. This is how we get a transaction received. And we had this on the homeworks in the past lessons. We know that this is how we implement. We are just porting that inside the backend. In the past 2 lessons, we ported that inside the frontend using WAGMI. Here in the backend, we can use a VM directly and have it to answer for those calls. So if I ask my token balance on this smart contract, for example, I can pass my address and it's going to answer my balance of. Okay. Tomorrow we are going to start on these minting tokens. for the post method, and we are going to integrate this in the front end. Okay. If you want to give a read on that documentation for tomorrow, is going to be very helpful. This might take 20 minutes or so. And then tomorrow we have about 1 hour, like 15 minutes or so of integration. And then we can do 20 minutes if we have more time, half an hour about oracles at the end of tomorrow's lesson. Okay. Good. The constructor, you are going to copy whatever you have in the get token name, and you're going to paste here in the constructor. Okay, and then you're going to have this public client here, as we defined in line 8, and we are going to reuse that in the future functions that you call. Okay. Dante, you raised your hand. Want to ask a question before we wrap up? Okay. Anything? Please feel free to open those GitHub issues. I'm not limited to 9 minutes per day. I'm going to help you all throughout the day, 24/7. As you post as soon as possible, I'm going to answer. Just take your time to open your GitHub issue there, and then I can go through your code, go through your issues, and help you to solve that. Okay. Thank you, people. We are progressing fast here in the full stack week. Thank you all for joining. See you tomorrow for more. Thank you. Bye-bye.